All right, so last section that we're going to talk about in chapter 11, 11.5, which is looking at the area of circles, which that we've already talked about. So just a quick refresher, the area of a circle is pi times the radius squared. Remember, you have to take the radius squared first and then multiply by pi. The other part of this section, the new part, is the idea of the area of something that we call a sector, which is basically, I've got a picture of a sector down here. It's basically a wedge in a circle. So it's a section of the inside of a circle that's formed when with a central angle and an arc. So this right here is what we call a sector. It kind of looks like a piece of pizza. And so we want to look at how to find the area of that sector. And we've already done how we find the length of just an arc, which is a part of the whole circumference. We took the measure of the arc divided by 360 times by 2 pi r, because that was the circumference. We'll need to, you'll notice the formula is very similar. And so it's the measure of the arc divided by 360, just like we did with the arc length. But this time, instead of multiplying by the circumference, which is the outside part, we're multiplying by the area. So this is the same thing as saying the area of the whole circle. So it's just the measure of the arc divided by 360 and then multiply by the area of the whole circle. Alright, so we want to find the indicated measure. We're trying to find the area of this circle with a radius of 2.5 centimeters. So area, radius is 2.5, is going to be pi times the radius squared. So pi times the radius squared. So again, remember the first thing when we do area that we have to do is we have to square the radius. So 2.5 times 2.5 is 6.25. And so we have pi times 6.25, and 99, you can type in your calculator. Either use your pi button on your calculator or 3.14 and type that in your calculator and you get about 19.63. And then remember, your area is always your units squared. In this case, we're talking centimeters, so centimeters squared. All right. Next, we'll look at working backwards. Here we're given the area, and we're asked to find the diameter. Now, there is not a direct relationship between the area and the diameter. So instead what we're going to look for is we're going to look for the radius, because we do know the connection between the area and the radius. Remember, the area is equal to pi times the radius squared. And if we know the radius, we can find the area. And so we set it up with pi times the radius squared equals our area. And in this case, our area is 113.3, so I just stuck that in for the area right here, equals pi times the radius squared. Next thing that I need to do is I need to divide by the pi, because I'm trying to solve for the radius. And if you divide by pi, you get about 36, depending on whether you use the 3.14 button, or the pi button, or just 3.14. Either way, you're going to get close to 36. It's just a matter of where the rounding happens. So we know that the radius squared has to be about 36. And so now we just have to ask ourselves, what does the radius have to be so that when we square it, it equals 36? Some of you may have already caught that. The other thing you could do is square root both sides. And if you take the square root of 36, you get 6. So the radius is about 6, but that was not our question. Our question was, what is the diameter? But if the radius is 6, the diameter would be 12. All right, so now we're going to look at an example of finding the area of a sector. Okay, so in this case, pay attention to the fact that it's asking for the sectors, both of them. You'll see in this picture I've got a red sector and a blue sector. I want to find the area of both of them. So in order to do that, I have the formula, but what I'm going to need to know is what the measure of each of the arcs is. Remember that this is a central angle, so the measure of this arc, the arc from U to V, is going to be 70, because remember, for a central angle, the measure of the angle and the measure of the arc are the same. Okay, I also will need to know, in order to find the area of the blue sector, I'm going to need to know arc USV, which will be 360 minus 270, which is 290. So I need to find the measures of my arcs. So the measure of arc UV is 70, the measure of arc USV is 290. Now I can just use those formulas for the area of a sector. So for the orange sector, orange, red, the smaller sector, the measure of UV is 70, so 70 divided by 360 times pi times the radius, which is 8, so times 8 squared. And then you can type that into your calculator. You can just type it in all as one thing. So you can type in 70 divided by 360 times pi times 8 squared. Or hopefully you know what 8 squared is in your head, and you could just, instead of typing in 8 squared, you could type in 64. But you should get about 39.10. And we don't know what units our 8 is, so we just put units squared. All right, we're going to do the same thing for the big sector, the blue sector. Only difference is we're going to use the measure of arc USV, which is 290. Radius is still 8, so, and again, we're just going to type that in the exact same way. 290 divided by 360 times pi times 8 squared. And you get 161.97. One thing you would notice is if you went ahead and just found the area of a circle, took pi times 8 squared, found the area of the whole thing, what you would get is the same thing that you'll get if you take 39.1 plus 161.97. So it ends up adding up to the same thing because those two sectors form the whole circle. All right, continuing on. All right, now this problem I'm giving you, so notice how this area is written over here. This area is the area of this sector. Okay, so we've got a 40-degree angle, and we're trying to find the area of the whole circle if we know the area of just that sector. Now to find the area of the whole circle, we just would need to know the radius, but the problem is we don't know the radius. So that's where we're going to kind of have to do a little bit of work. One thing we know is that the one thing we do know is the area of the whole of that sector, and we know the measure of its arc. The arc is 40 degrees. So if the area of the sector is 35 and the arc is 40 degrees, what we can start with is we can use our formula and say that the area of the sector is 40 divided by 360 times pi r squared. So we're going to stick 35 into here, and we're going to stick 40 into here. And I want to point out this right here is the area of circle V. Okay. So in this particular problem, it actually turns out that we don't have to find the radius at all. Okay, we just need to get this section by itself. So I plug that in, and so instead of leaving this as pi times the radius squared, I just wrote it as the area of circle V here. Okay, so then this simplifies down to 1/9. And so 35 is equal to 1/9 of the area of circle V. So then to get rid of the 1/9, I just need to multiply by 9. And then that's going to cancel out, and whatever's left is going to be equal to the area of circle V, which is 315. Okay. Now again, you could have left it as pi times the radius squared instead of changing it to the area of circle V, and actually solved for the radius. You would have then divided by pi, took the square root, that would have given you the radius, but then you would have turned around and then plugged pi times the radius squared and got right back to your 315. So this is just a little bit of a shorter way of doing it. All right. I think just one more example, and then just some extra practice. So one more specific example, new example, and then the rest are just extra practice examples. All right, so here we're trying to figure out how much wall needs to be painted. Okay, so figuring out area in terms of painting is a very common way of using area. Is okay, how much area do I need to paint? So how much paint do I need to buy? You don't want to make too many trips, and you don't want to end up with a whole surplus of paint left over. So you want to try and get it as close as you can first time. So we need to try and find the area of this, and you'll notice that basically what it is it's just a rectangular wall with this door cut out of it. Okay, and the door's got a circular window. The door cutout is a square. And we can tell it's a square because this is 16 here. And then you can see this is 16 over here. Alright, so then the other thing that you need to notice is that, so as I said, we've got this square. We also need to figure out the area of this semicircle. And so that's going to be Alright, now my pens should work. Alright, so that's 8. I just want to point out, don't get that mixed up with this 10 here. So don't think the radius is 10. Notice how there's this little part above the circle that's still going, so that's not going all the way up 10. We can tell that this is 8 because this is your diameter. It's 16, so 8 and 8. Alright, so that being said, we kind of know all of our dimensions now. We know that what shapes we're dealing with. So what we need to do is we need to start by finding the area of this rectangle. And area of a rectangle is just going to be the base times the height, or length times width, whatever verbiage you want to use. So 36 times 26. And then we need to subtract out the square, which is going to be 16 times 16. We need to subtract out this semicircle, which is going to be half of pi times 8 squared. Half because it's a semicircle instead of a full circle. So this right here is your area of the rectangle. And then I'm subtracting out the area of the square. And I'm also subtracting out the area of the semicircle. Okay, so then I just figure out what those things are. That's 396, that's 256, that's about 100.53. Type that all into your calculator. And or just write it twice. Sorry about that. Just a little more build up on the answer there, I guess. So 579.47. And it's feet squared because it's feet. All right, so these last examples are just some extra practice. So if you feel pretty confident and you want to just jump into the homework now, go for it. Otherwise, stick with me if you want a little bit of extra practice to make sure that you know what's going on.